In a polygon of n sides, how many diagonals do we have? So let me try to answer this using two different approaches. Let us start with the first approach. In this one, let's say that I have a polygon of, let's take a simple example, and let's say I have a polygon of 5 sides, and through this we'll try to understand about the polynomial of n sides. So this will be a simple pentagon. Okay. Now how will I form a diagonal? For a formation of a diagonal, I need 2 points, starting point and an ending point. Let's say this is the point from where I start. Say this is my starting point. Now I cannot choose this or this because they will give me the sides of this pentagon. So I can choose either this point or this point. Similarly, let's say this is my starting point. So I cannot choose this or this. I can only choose this and this. So in that matter, I can form the diagonal of this pentagon. Having said that, the number of diagonals in this case will be, I can choose any one point from these 5 points available here. So that will be equal to 5c1, choosing any one point from these 5 points available here. Let's say that this is my first point. Now the end point, it cannot be this, it cannot be this, it can either be this or this. So basically, how many points do I need to eliminate? 1, 2, and this point itself, because this cannot be the end point because this is the starting point. So I have to eliminate 3 points. Number of points available is only 2. So out of these 2 points, I have to select any one point in order to form a diagonal, that is this and this. But one more important thing to take care is that similarly, this one point that I'm choosing as my starting point, now this starting point can either be this. If this is my starting point, I cannot choose this or this. I can only choose this one or this one. So I'll get again this diagonal and this diagonal. But again, I am repeating the same diagonal that I have already counted, taking this as my starting point. Similarly, if let's say this is my starting point, I cannot choose this or this, but I can choose this one and this one. So this will be my diagonal and this will be my other diagonal. But this diagonal I have already counted because considering this as my starting point. So whatever diagonals that I am getting through this expression, they will be double the number that we require because we are repeating everything. This can be starting point, this can be ending point. For the opposite case, this can be starting point, this can be ending point, but still I am getting the same diagonal. So this total value I have to divide with a 2 in order to get total number of diagonals. Once we are done with this, now let us generalize this for a polygon with n sides. For n side, let's say that this is some random polygon having n sides. Out of these n points available here, I have to pick any one point as my starting point. So that can be done in NC1 ways. I can either pick this or this or this, any one point out of these n points. Let's say this is my first point. Second point I can get. In the second point, in that case, I cannot pick this point or this point. So out of total n points available here, I have to subtract 1, 2, and this point itself, total 3 points. So n minus 3 will be total n minus 3 points available, and out of these n minus 3 points, I have to pick another point which will act as my ending point. So n minus 3, out of these n minus 3, I have to pick any one point to get a diagonal. But again as we discussed here, these are the double the number of diagonals that we require. So I'll divide this with a 2 in order to get the total number of diagonals. Now let us solve this. NC1 is basically n minus 3 C1 will be n minus 3 divided by 2. So this will give me the total number of diagonals that I require. We can check this by substituting n equals to 5 because we know that the answer will be how many diagonals do we get here. So this value is equal to 5 times 2 upon 2, that is equal to 5. If I'll substitute 5 here, 5 times 5 minus 3 is 2 upon 2, I'll again get a 5 from here. So this was one of the ways of understanding how many diagonals can I get in a polygon of n sides. Let us try one more approach for this. let's say again I have a polygon of 5 sides. Let's take an example of 5 sides. Now, if I would have considered sides as my diagonal, though that is not allowed, but if sides are also included in diagonals, then the question would have been much simpler. Out of these 5 points available, I can pick any 2 points and form a diagonal, because sides are also considered as diagonal if I am assuming that, though that is not correct. But still, let us say that if that is correct, so out of these 5 points, I can pick any 2 points. It can be consecutive points, it can be non-consecutive points, but still I'll get total number of diagonals. But since the sides are not diagonals, we need to subtract sides as well. And how many sides do I have here? 1, 2, 3, 4, 5. So I'll subtract 5, because these 5 sides I have considered as my diagonals as well. So out of 5C2, I'm subtracting those 5 sides in order to get the total number of diagonals. So this value will be equal to 5 factorial upon 2 factorial upon 3 factorial minus 5. 3, 4 times 5, this will be equal to 2 times 5. 2 times 5 is 10, 10 minus 5 is 5, which will give me total number of diagonals. Let us generalize this. Now let's say that I have a polygon of n sides. If I need to form a diagonal, and if the sides are also considered in diagonal, total number of diagonals will be nc2. But since sides are not the diagonals, so I will subtract total number of available sides, that is n. So nc2 minus n will give me total number of diagonals in this n-sided polygon. You can solve this as well. This will be equal to n factorial upon 2 factorial times n minus 2 factorial minus n. Now this thing is equal to, this will cancel out, this will become n times n minus 1. So this is n times n minus 1 upon 2 minus of n, which is equal to n square, minus n minus 2n upon 2, which is equal to n square minus 3n upon 2, and this value is same as that we got earlier, n times n minus 3 upon 2, which will give me total number of diagonals in n-sided polygon.